let's talk about odds. Now, odds are expressed in the form of a ratio. And you'll see that typically as A colon B, or just written out as A to B, like that. Typically, you're not going to see them as a proportion, as a fraction, although it does relate to fractions and probabilities. But there's a couple different odds we're going to work with. We're going to work with the odds for something and the odds against something, and then the payoff odds. So, and we can also look at the true odds, etc. So a lot of different odds going on here. And what I want us to start out with is kind of a friendly example where the number of things that we're dealing with is kind of small. So again, odds against an event are A colon B. Then the odds in favor are the opposite of that. Let's take a look at this example. So I've just drawn 5 squares, 3 pink and 2 blue. And I want to look at the odds against randomly choosing a blue square. So odds against, that's going to mean the number of ways that it won't happen. How many ways are there you can avoid choosing a blue?
3 to 5.
3. There's 3 ways against. How many ways for? 2. So those are the odds against randomly choosing a blue. 3 times you won't, 2 times you will. So those are the odds against. What if I flip this around and ask, what are the odds for randomly choosing a blue? So instead of the odds against, I want the odds for. How does that change things? What would be my new set of odds here?
2 to 3.
2 to 3. Thank you. Yeah, 2 to 3. So beautiful. Now you can figure out the probability of choosing a blue just by looking at this right here. There's 2 out of 5, but I want us to think of it based on what we see here. And what we're seeing here is how many possibilities there are. There's 2 that are blue and 3 that aren't. So that gives you your total. There's 5 things that can happen. So the probability of a blue is really the 2 that are blue amongst the 2 plus 3 or 5 things that can happen. So that's how you can go from odds to probability. Now we're going to do a couple examples like that, and they might get a little bit more challenging, but we'll do our best. Odds for an event happening. Yes? No, because there's 2 ways that can happen and 3 ways that it doesn't. So we're not looking at a probability here. This is the probability that's related to this. But if you're looking at just the odds, 2 times it'll happen, 3 times it won't. That's the ratio of those things that you're going to get. Is that helping out? Okay, thank you. Let's take a look at example I, and that's right here. For a certain horse race, the odds in favor of a certain horse finishing in second place are given as 20 to 80. Express the indicated degree of likelihood as a probability value between 0 and 1 inclusive, and we'll worry about the payoff odds and the actual odds, etc. in just a minute. So this is example I. And I want the odds for finishing second. So what you want to form the ratio of is the number of ways to finish second and the number of other ways. Number of ways not to finish second. So that's going to be your ratio. And they all but give it to you here. Can anyone tell me what that ratio would be? Nice, it's in lowest terms, thank you. Let's start out with it in terms like this. The first pass at this is, there's 20 ways you can finish second, 80 ways that you're gonna finish something other than second. Now, Dimitri noticed something that you can do here. If I wanted to, I could put this kind of in lowest terms. And I'm gonna treat this like an equation and divide both sides through by 20 and put it in lowest terms. So divide this by 20, and of course, neither of my markers is working. Whatever. So I'll divide by 20, thank you. And that's gonna give me 1 to 4. Those are effectively the same odds. 20 to 80 or 1 to 4, those are effectively the same odds. The only difference is that this is in lowest terms. So that might be helpful sometimes, is to divide both sides by something. That's in lowest terms. So great. That's the first question that they asked, was express the indicated degree of likelihood as a probability value between 0, or no, it's not the first question. My first question was to express it that way. But let's figure out the probability. You can use this one or this one. It's going to give you the same thing. So the probability of finishing second, probability of second place finish. Let's start out with the denominator. And I'll go up here to do that. How many possibilities are represented by this ratio? How many things can happen when we look at this race?
100.
100. Thank you, Grace. 20 plus 80 is 100. How many of them represent a favorable outcome?
20.
20. So you get 20 over 100, or 1/5. You get the same thing if you did it here. You could say, all right, well, that's 1 way out of 1 plus 4 is 1/5. So it doesn't really matter which pair there you choose. They both work. Okay, so far with odds. Let's try one more. Now our payoff odds is the actual odds against winning, or excuse me, if the payoff odds are the actual odds against winning, how much profit is there from a $10 bet? So here's our odds against winning, and let me go to a different sheet. So odds against winning, and that was 1 to 4. So if our payoff odds are that, let me describe to you what the payoff odds represent. Payoff odds are a ratio from the amount bet to your net profit. That's what the payoff odds are. Let me zoom out a little bit so I can get that in there for everyone. Amount bet to your net profit. Okay. So back up to the question then. With our ratio of, let's see. But you know what? I got this backwards, don't I?
Yeah.
Yeah. So the odds against winning were 4 to 1. So I want to keep that in mind, because the problem asks you, if the payoff odds is the actual odds against winning, how much profit is there from a $10 bet? So we've got 4 to 1. I want the amount bet to be 10 here, right? So that I can figure out how much profit I get. And I'm going to treat these dots as kind of like an equation, like an equal sign. So I'm just going to multiply both sides by 10. So this is my amount bet. And this is the net profit. Are you okay with our calculation of our net profit? We got one more coming like this. I think the answer is 40.
Okay.
So, I mean, that's what the net profit is. So if you're typing this into my math lab or something like that, it would just be 40 would be your final answer there. Thank you. Exactly. Exactly. Yeah, I accidentally copied down the odds for winning. The odds against winning are 4 to 1, and that's what they're going to use. I mean, that's what they should use for your payoff odds. Now, in actuality, they don't use that for your payoff odds. They use something different, and we'll see that difference and what it makes in the next example. But you're exactly right, Skylar. Anything else on problem I here? Let's move down to problem J, or example J. And this one is just taken directly from your homework. They've taken and modified a slot or a roulette wheel, which normally has 36 possibilities, actually 38 possibilities, and this one only has 28. So, okay. A modified roulette wheel has 28 slots. One slot is 00, another one is 00. And the others are numbered 1 through 26 respectively. You're placing a bet that the outcome is an even number. In a roulette wheel, 0 and 00 are neither odd nor even. What's the probability of winning? So let's work with that first. So this is example J. So the probability of winning, the thing to know about this is that each one of the slots on the roulette wheel is equally likely as you spin that ball. There's an equal chance that they go into all of them. So if you want to figure out the probability of winning, you first of all got to figure out the denominator. How many possible slots are there?
28.
28. Keeping in mind that 0 and 00 are neither even nor odd, the number of evens and odds comes from the remaining numbers, the remaining 26. So if you got 26 numbers, how many of them are even?
13.
13. And that's your probability of winning. So that's part A. Yes. Because if you have the numbers 1 through 23, excuse me, 1 through 26, half of them have to be even, right? So 2 is even, 3 is not, 4 is even, 5 is not, 6 is even, and so on. So just the numbers that are multiple of 2 are going to be the even numbers, and that's going to be half of this set of numbers here. It's okay there? You're welcome. Appreciate the question. Now, what's the odds against winning? So here we got to think a little bit about this. And let me separate this denominator a little bit. If there are 13 ways you can win, how many ways are there that you can lose? 15. So again, this is ways you can win. Well, I know that there's 13 of the possibilities that you get when you roll this ball are winners, right? So that means the rest have to be losers. So this is 28 minus 13 gives you 15 ways you can lose. Does that help out a little bit? You just get it by subtracting. So these are the, all right, good. Now I'll look at that as part of my work for part B here. It says, what are the odds against winning? Now what I'm looking for here from you is for you to do a ratio. Why don't you put your answer in the chat to me privately so I can see that you're out there and you're following me. Or maybe you're not following me, in which case I got to do some work here. So what are the odds against winning? So that's part B. And still looking for that first number in the chat. Awesome. Thank you, Jaron. Anyone else? Victoria, thank you. Cody, Philip Pater, you gave me a probability. Justin, that's the first part's right, but think about the second part. The odds against something are going to be the number of ways you can fail versus the number of ways it can actually work. So how many different ways are there that you can fail to win?
15.
15, thank you. Someone else now. How many ways are there that you can actually win? 13, nice. All right, so there we go. Those are your odds against winning. 15 times you lose, 13 times you win. Beautiful. When you bet that the outcome is an even number, the payoff odds are 1 to 1. How much profit do you make if you bet $18 and win? All right, well, let's take a look at that. So the payoff odds are 1 to 1. Remember, this is the amount bet. And this is your net profit. Okay, but I wanted to bet $18. What do you think I can do to figure out how much that $18 bet is worth? Yeah, we're going to multiply both sides of this by 18. In particular, I'm most concerned about the right-hand side. That's going to give me $18 bet is worth $18 profit. Okay, so you bet 18, you win 18. Easy math, right? Let's look at part D. How much profit should you make if you bet $18 and if you could somehow convince the casino to change the payoff odds so that they are the same as the actual odds against winning? Now, this is what you should be getting when you go to the casinos and place your bets, is the actual odds against winning. So those odds against, one more time, were 15 to 13. I'm going to do this in 2 steps. It was pretty nice when I had a 1 here, right? When I had a $1 bet, all I had to do was multiply by 18 and I was good. So what I'm going to do first is I'm going to get a 1 here. How do you think I'm going to get a 1 where that 13 is? Divide by 13. Well done. And that's going to give me 15 over 13 for every $1 bet. All right, that's great. I still want to figure out how much an $18 bet is worth. So now what am I going to do? Multiply. Perfect. Multiply each side by 18. So that's going to give me $18 bet. And I'm not sure I can do 270 divided by 13 in my head, but it's going to be a little bit over 20. $20.70-ish. Somebody help me out. 20.77. So 20.77. So this is what you should be making, and that's what they actually give you. That's how they can pay their light bills. That's how they can stay in business, is they're not giving you as much as your bet is worth. So you want to be careful. There's a lot of places when you're gambling, not only in Vegas, but in downtown, where you can get, closer to the true odds. Now, the difference between this and what they pay you, that difference is called the vigorish, or the VIG for short. You want that vigorish to be as small as possible if you're going to gamble and try and win. Now, there's some good bets and there's some bad bets out there. I constantly grapple with this when I do hit the tables, which is rare if ever, but I do hit the tables from time to time. There's places when you're playing the games of craps that if you bet $6, you win $6. Or with the same risk to your money, you can bet $6 and win $7. That's 18% more on your money for free. Who wouldn't do this? But I see people making this bet all the time. That's because they don't understand that the game that they're playing. They could actually give themselves an 18% better chance at surviving in this game than they are. But they don't. So my message to you is if you're going to gamble, be smart about it. Learn the game that you're playing and try and master it. There's some good bets and some bad bets out there. Try and make some good bets if you're going to gamble. But all these casinos should probably have a sign on the outside door that says, if you come to win, don't come in. Because in the end, if you stay there long enough, you're going to lose. The odds are just stacked against you. So if they weren't stacked against you, then these places wouldn't be able to stay in business. Comments or questions on odds and probabilities? All right, let's call it a wrap on this. Question?
Question C again? I got A, B, and D, just not C.
One more time? Oh, okay. You just want to see that one more time?
Yeah, thank you.
You're welcome.